I think it's partly because I sometimes don't care to warm up, but did that, you good now, Damien?
Yeah, I'm good.
Cool. So again, that's just something that you just literally state. You just always do it. Tack a k-1 in there wherever you see an n. So now we essentially want to use this to show that it's also true for k. So for the inductive step, oh, what have I done? What did I do? That was weird. Okay, I didn't know that was a thing. Anyway, so for the inductive step, I'm going to write out a little bit more than you really need to. I want to remind us that we want to show, so abbreviating that if we plug in a k everywhere we see an n, that will hold. So essentially what we're going to be looking for is we're going to start with the left side, and we're going to really, really hope that after a bit of algebra, we can come out to the thing on the right. It's frozen. No. Oh, well, and share and reshare it anyway. So we're going to start on a test for the EIH. We literally just write that. Yep, pretty much. You just say assume that the thing you're trying to prove is true for k-1, and you just have to say for is true for k greater than 1. So yeah, you can essentially write it out just like that. It's perfectly fine. So we want to take the thing on the left, somehow find the inductive hypothesis inside of it, and then do a little bit of algebra fun times to get the thing on the right. Now, with these ones that include sigma notation, I want to choose my words carefully here. It's quote unquote easy to find the inductive hypothesis because it's always the same type of idea with these sigma ones. Because if you, whoops, good to do. If we're starting with the sum from, whoops, what's wrong with me? From I equals 1 to k, we can break that up into the sum. So maybe I should do this first. Remember that this is essentially 3 times 1 plus 3 times 2 plus 3. You don't see anything? Hold on one second. 3 times 3, unshare, reshare. And then we keep adding until we plug in k-1 and then k. So remember, that's how the sigma notation works. We're essentially plugging in natural numbers all the way up to whatever that highest number on the sigma is. So if you notice, essentially this first piece, hopefully that worked. Let me know if it didn't. But that first piece, not that first piece, that first chunk, essentially everything but that last term, is exactly the sum from I equals 1 to k-1. So you can always break these sigmas into, you can essentially break it up wherever you want. But essentially the thing we're going to want to do is we're going to say that this is equivalent to the sum to the k-1 term plus that last term of 3 times k. The reason you do that is because this thing you've just broken it into is exactly the front piece, if you will, of the inductive hypothesis. I've found the inductive hypothesis in the thing I'm trying to prove. Okay? So you take the left side, try to find the inductive hypothesis there somewhere. The question is in there. The thing you can't see is just saying, hey, this isn't a warm-up and we're going to talk about it together. So everything that needs to be in there is on there. The actual question is right here. Use induction to prove. It hasn't caught up with me. I circled the dot in red. Hello? It's me. No? Oh, it's, yeah, not really catching up at all. Did it scroll up when I scrolled up? It did? Yay! Magic. So yeah, the question's at the very top. Use induction to prove the sum thing equals the other thing. So yeah. So I'm going to hold on a second because I do need to scroll down. So just in case you need to write that down really quick, I'll leave that up there for a second. So again, the point is that I started with the thing on the left of what I want to prove. I've found the inductive hypothesis within it. And now I'm going to be able to replace that inductive hypothesis into what I'm trying to work with.
Was there anything above that? I see like some words.
It was just saying that we're going to start it together, so it's not technically a warm-up. That's all they're doing.
Okay. All right.
And I mean, it was just a continuation of a thing that I had before, so.
Got you. Thank you.
Yeah. So now that I've found the inductive hypothesis, I get to replace it with what that inductive hypothesis is equal to. So maybe I should stop calling it the inductive hypothesis, because the inductive hypothesis is technically two things. But I found the left side of the inductive hypothesis, and I can replace it. Yes, sorry, I was just reading the thing that just popped up. But yeah, I paused halfway through my sentence. We can replace it with what's on the right side to save time. Could we just write instead of 1 through 3? Yeah. I mean, you don't even have to write that step necessarily. I was just trying to remind us what the sigma notation was. If you wanted to like start here and then just jump to this step down here, that's perfectly fine. You don't have to write out that expanded form if you don't want to. But, so I gotta scroll down a little bit. So we have the left side of the inductive hypothesis. So what we're going to do is we're going to replace it with what it's equal to. So that right side of the inductive hypothesis, essentially. And then the 3K still needs to be there. So that's using my inductive hypothesis. I've already said that the sum from 1 to k minus 1 is equal to that nasty thing that I just plugged in there. So I can replace the sum to k minus 1 with that thing. Once you've used the inductive hypothesis, now it becomes an algebra game. Now, what's the point of the algebra game? What we're trying to get to is we're trying to get to this thing that I highlighted a bunch. So we want to try to manipulate what I have to look like some 3 times k plus 1 all over 2. So right now I have two things, and one of them is not over 2, so I should probably go ahead and put it over 2. So that's probably the first thing I should probably try to do, is I should probably make a common denominator. Let me also do one tiny step as well, and I'm going to go ahead and simplify this k minus 1 plus 1 to just k. So if I want to put this over 2, I have to multiply the numerator up by 2 as well. So once it catches up to me, magic. We get 6k over 2 instead of 3k. Hopefully, if I squish these together, I'm going to be able to get to 3k times k plus 1 in the numerator. So, well, let me do this first. Let me distribute the 3 and distribute the k. Hopefully, I can distribute them at the same time and not freak anybody out, but tell me if it does. So we'll get 3k squared minus 3k over 2 plus 6k over 2. Common denominator means that I can just squish those together. And why did it become a 2? I'll talk about that in just 1 second. So the 6k, essentially I have this 3k right here, and I want to add it to this other term, but the other term is over 2. So I essentially need to turn 3k into something over 2. So if I think about this as 3k over 1, if I want to turn it into over 2, I would have to multiply the numerator and the denominator by 2. It's not catching up to me. Eventually, it'll show what I just said. So essentially, we have to multiply that numerator by 2 to get 6k over 2. I can't just put it over 2 without changing the numerator. So once I squish those together, I'm trying not to scroll down again. We can combine together the 3k, well, minus 3k and the 6k. That'll become 3k squared plus 3k over 2. Let's take a break for a second and remind ourselves what we were looking for. What we're looking for is towards the top of the screen, highlighted a bunch. 3k times k plus 1 over 2. I've got an over 2. I've got a 3 floating around in there. And also notice that the numerator has a 3k in common in both terms. If I pull that out, I will have exactly what I want, that 3k times k plus 1 over 2. So if I scroll down just a tiny bit, if I pull out a 3k from that numerator, what I've gotten is equal to the thing at the very top of the screen that's highlighted. There it is. So what I've done is I've taken the left side of what I wanted to show, the sum from 1 to k of 3i, and I found the inductive hypothesis, I replaced the inductive hypothesis, I did a bunch of algebra, and I came out to the right side of what I wanted to prove. Yes. You got 2 terms of it. So the question, if you didn't hear on Teams, is how that factoring came to be. Like, why does that become 3k squared plus 3k to 3k times k plus 1? So you start with 2 terms. So the thing that is being factored out of needs to stay 2 terms. So you have 3k squared. What happens if you take a 3k out of that? You're left with 1k. What if you take a 3k out of 3k? Well, technically you take it all away, but you do kind of need that placeholder to remind us that it actually existed, because if you think about distributing that 3k back in, if you don't have the plus 1, you're not going to get the 3k that we had. So since it starts as 2 terms, the factored out form also has to, I need to be careful with saying 2 terms. 2 terms in the piece that gets factored out of. Does that make any sense? Any more questions on that one? Because, well, we're done. Technically, you should say, I don't really want to scroll down anymore, so maybe I'll just like shove it over here. You should say by induction, essentially the thing you were asked to prove, the thing up to n, what was it? 3n n plus 1 over 2 for n greater than or equal to 1. At the very end, it changes back to n greater than or equal to 1 because we showed it was equal to 1 was fine in the base case, and now we've just shown that it works for anything greater than 1. In just 1 second, because some people are trying to write down what I just wrote. Let me try to zoom out a little bit, maybe. Maybe that'll be. I'm rewriting the question because the question is the only thing that didn't get on the screen right now. So what I just wrote really large on the side was the original question, and now the entire work has now been fit on the screen.
If on the sigma notation, if the I wasn't 1, like if it was 2, how would that change?
So I had a question of if on the sigma notation the I started at 2 instead of 1, what would change? What would change is essentially just the base case. You would just then have to plug in 2 instead of 1. Everything else would stay the same. After proving the base case, you would just go ahead and assume it's true for k minus 1, and so it's true for k. So if that number at the bottom changes, the only thing that's going to change is the base case. Let me finish this so that if people look at it later, they know that that was what I was doing over there. Any more questions, concerns on this one? All right, I'm going to have you guys try one more because I was going to have the warm-up be 2 of them. So now that we walked through one very lengthy together, I'll try to leave it up. So maybe I'll write the question over here and then I'll move it when we have to go over it. But I'll write the question down here in the corner. We want to prove using induction. This one doesn't have fractions. Yay! The one on the quiz doesn't have fractions. Yay! Anyway, I equals 1 to n of. This one does have like the tiniest bit more algebra in general. There it is. It doesn't have any fraction algebra, but it does have a bit more algebra. I think. Yeah, a little bit. But I'm going to have you guys try that one first. So this is kind of like your warm-up. And I'll leave that last one up for reference. So I'll give you like 5 minutes.
Minus
2n minus 1, yes. As similar as probably it could get, I guess. Essentially both of these are similar to what you'll see on the quiz. The quiz doesn't include fractions. So I guess this one that we're doing right now is probably pretty close to what you'll see on the quiz. I will say, not to freak any, but no, it's not going to freak you out at all. When you get the quiz, it has a lot more exposition in the question, but like you'll see something like this at the bottom of the question. So don't get bogged down in the kind of extra exposition that's at the beginning. If you just want to focus on the thing you want to try to prove. Anyway, I'm going to stop talking so you guys can try that. Anything above what I've scrolled up to, you don't need to worry about, so.
I was just confused looking at it. You go from K to K minus one.
Yeah, so that's what have the sigma here, then you break it up into the sigma to K minus one plus the last term.
What is the last term?
So the last term is going to be, so they're missing,
So they have to put extra in it, minus one.
so. This is it. And down to that 30 minus 30. And what we do is we can use this sum up into essentially the sum that all should be there. Okay, so this n and this n only. If you came with. Oh, well, then I guess that should be it. Oh, I did put n, didn't I? Whoopsies. That should have been I. Yeah.
Y'all probably didn't even think about the notation and just did it anyway. But this should have been an I down there, not an N.
So K minus one is not.
Correct. I'm sorry.
Gotcha. That makes it
So you split this sum into the sum from 1 to K minus 1 plus the last term, which was English. The last term of this sum would be plugging in K. So you get 4K minus 3. So if you split this up into the sum from 1 to K minus 1 plus 4K minus 3.
Let's start talking about it. What up?
I'm still confused, like, when you write out the sequence like that,
Mhm.
After the 4k minus 1 minus 3, where do you just
Oh.
get the by itself k? Like 4k minus 3?
I did make a tiny. Where do I get this?
Just the k part.
So this thing
Mhm.
is telling me write this term out a crap ton of times,
Mhm.
starting with plugging in 1 and then plugging in 2, and stop when you plug in a k.
Mhm.
So I plug in absolutely every natural number between 1 and k. So essentially I'm saying I'm writing this term because I want to show that this shows up there. But I start with 1 and I do every natural number, which includes the number before it, but then I stop when I plug in
Oh,
k.
okay. Makes sense.
All right, let's start talking about this one. Do you want to, just because it's a 145 and. Should probably make you go outside, but yeah, go out in the hallway. Let me just clean this up a little bit for later because I'll post this on Blackboard. Hopefully I remember to do that. So now we're doing prove. Yeah, sorry about writing an N there. That was completely my bad. Base case. N equals 1. The brain 1. And then plug it into the other side as well. So 1, 2 times 1 minus 1. 1 times 1 is 1. 1 equals 1. Inductive hypothesis. You just assume it's true for k minus 1, wherever n is. And say for k greater than 1. And then the inductive step, you start with the thing on the left. Hopefully come out to the thing on the right with a bunch of stuff in the middle. What? Inductive step. So we start with the thing on the, well, I should be careful. We start on the thing on the left, but with k, because now I want to show it's true for k. But remember, the other point is that we want this inductive hypothesis to show up. Well, with these sigmas, if the thing that I have right now is saying I'm taking the sum from 1 to k, I can split that up as the sum from 1 to k minus 1 and then just tack on that last term of k at the end. Because I do need to include it, but I can rewrite this as the sum from 1 to k minus 1. But then I have to take care of that last term of k that the original thing had. So if I plug in k to that, I'll get this. I should probably put the big thing in parentheses if I want to be really, really good about it. And now this thing, this sum to k minus 1, I know is equal to this thing. So I can replace it. And I know there's some simplification we probably could have done first, but we'll do that now in the algebra party we're about to have. Let me keep those for now. They don't matter, but. So again, once you've found the inductive hypothesis and replaced it, once you found the one side of the inductive hypothesis and replaced it with the other side, it becomes an algebra game. So let's remind ourselves what we're looking for. I'll kind of come off to the side and want to find, well, I want to find essentially this thing, but with k replaced in instead of n. So we want to find some, what? We want to find some k, 2k minus 1. So we want to try to take what we have right now and try to somehow get a k times 2k minus 1 out of it. So the first thing we should probably do is just smush it together as much as possible. So I would distribute this 2 first. Well, really, I don't really know what else you could do at that point. 2k minus 2 minus 1. I would simplify that subtraction in that second term a little bit to get minus 3. Now to go any further, I'm going to have to FOIL that kind of first 2 things that are multiplied together. Or distribute if you like to. I think most people usually have heard FOIL before in their lives. First outer, inner last, you multiply all the things together. So we get 2k squared minus 3k minus 2k plus 3. And then the 4k minus 3 drops down. Let's try to smush together as much as possible. We've got a 3 and a negative 3. Those are going to cancel each other out. We're going to get 2k squared. And then we have negative 3k minus 2k plus 4k. Negative 3k minus 2k is negative 5k plus 4k is 1k. Plus k. We're trying to find k times 2k. So yeah, sorry, it should be a minus k. We had a negative 5 plus 4. Yeah, sorry. Negative 5 plus 4 is negative 1. So if we want to try to transform that into k times 2k minus 1, all we have to do is factor out the k that they have in common. We get exactly what we wanted by induction, the thing we wanted. So, okay, let me be good about it. By induction. Frozen. No. By induction, we now go back to using the n's. N 2n minus 1 for n greater than or equal to 1. Questions, concerns? Raise your hand, and you can also do it on Teams if you want. If you like go to the middle or wherever the options bar is, there's a raise your hand option. Raise your hand if you want another one. Yeah.
Wait, want to know what?
Raise your hand if you want another induction question. So I have 2 people online. Okay, cool. 4 people. 5. Okay. We'll do another one. Okay. All right, we'll do another one. I need to find what. Well, I actually pulled it up. Let's see. Can't do that one because that's the one on your quiz. Huh?
Is there just one on the quiz?
Yeah. Let's see. I don't know. know, they're all so similar. Let's do one without fractions again, because the one on your quiz doesn't have fractions. So we just did that one. So why don't we do this one? So we won't get to any new content today, but that's okay, I guess. It'll be all right. So it's probably the last one we'll have time for. We're running out of time. But say you want to prove by induction. I'm not going to write by induction because I'm getting lazy at this point. From 1 to n of 4i equals 2n n plus 1. I'm going to have y'all try it again. In a second, I'll zoom out a little bit and try to scroll back up for that last one. But so people can write that down really quick. Okay, let me try to zoom out and get some of that last problem in there for reference. It's not all of it, but, well, it's frozen. I'll give it a second. It's got a good bit of that last problem in there, not the full thing, but hopefully enough. Matthew, I was actually going to suggest that, well, maybe not suggest, but tell all of you on Blackboard that that would be an option. If you wanted to write it all on paper, and then just send it to me, that's perfectly fine for the quiz. Because I think writing it out on paper will be easier than trying to type it into Blackboard.
Thank you.
So, right, so I like this part. I'm just saying, see how the n plus 1 is in parentheses? Or k plus 1, k minus 1 plus 1 should be in parentheses. Not that one. But, That looks good to me.
It's good to start with.
That's like halfway through, but yeah, that's fine. So now it's the algebra game. Yeah, so I'll get started. But yeah, yeah.
So I forgot to tell y'all earlier, I meant to bring your exams to give them back to you, and I forgot them, so you'll get them back next week. If you want to see it sooner, email me, and I can send you a scan of it, but.
Are you going to do the same thing like you did last time where you accumulate our overall grade?
Yeah, I've been meaning to do that. I just have not, literally had not have the time, but it should. I'm gonna do that by tomorrow night. So by tomorrow night, you'll have your current grade after the exam.
Okay, thank you.
Yeah. All right, I'll give you another minute, 2 minutes. All right. For the sake of, we gotta do it before we need to take a quiz. I'm gonna start this. Scroll down, you silly. There you go. Well, once it catches up, let me just force it to catch up. There we go. So base case, n equals 1. That sum side will just be 4 times 1, so 4. That other side will be essentially 2 times 2, so 4. 4 equals 4. Base case is done. Inductive hypothesis. We want to assume that this entire thing is true for k minus 1. I forgot to say assume. So assume that is true for k greater than 1. Inductive step. So I'll just remind us what we want to show. You don't have to write the want to show thing. If it helps you, you totally can. But so we want to show that it's true for k. What am I writing? So we're going to start with the left side. Since it's a sigma notation sum, we can essentially split it up at the k minus 1 term. But then we need to include that last term that sum then doesn't take care of, which would be plugging in k, so 4k. And now the point is that we've made the one side of the inductive hypothesis show up, so we can replace it with the other side of the inductive hypothesis. Sorry, that's not my inductive hypothesis. That's one reason why maybe you shouldn't write that. But sorry, inductive hypothesis was up here. And once you've found it and replaced it, it becomes the algebra game. So, I would simplify that kind of third term, if you will, first. To get, well, just k, actually. Then we've got to distribute. I'm going to hopefully distribute the 2 and the k at the same time without freaking anybody out, but if it freaks you out, let me know. Negative 2k plus 4k will give us plus 2k. If what we're trying to get is this, I can get there from what I have now by just pulling out a 2k. Be left with k plus 1, which is exactly what I wanted by induction. The thing we wanted to show all the way up through n is equal to what was it? 2 n plus 1. Not that bad now.
Now, let's hurry.
Hurry before it slips out of my brain. Questions and concerns on that one? So seriously, this is what I meant by once you have the process down. Actually, I don't know if I said this out loud. Once you have the process down, the quote unquote hardest part of these, and I don't mean to say that to make anyone feel bad if they think another piece is hard. But once you have the process down, really the hardest piece is the algebra. Because as long as you're keeping in your brain base case, write out the inductive hypothesis, find my inductive hypothesis somewhere, replace it in, most of the actual work just comes from algebra manipulation. Questions, concerns? All right, I need to force the quiz to show up on Blackboard because we're a little bit early, but we don't got time to do anything else, so. Dang it. That means you can't finish your homework now because we didn't get to 3-5, which was supposed to be today. I can, but then I gotta extend it so much farther, and then it's just a I don't know, I'll figure it out. I'm just complaining. Okay, I'm gonna stop the recording. People on Teams, please put your web